Welcome to another lesson. This will be the last lesson in our Unit 7, learning all about the wonderful theorem, Pythagorean theorem. And we're just going to do a little review of what that means using the Pythagorean theorem, both regular way and the converse way. So first of all, let us review how to find the hypotenuse. So to find the hypotenuse, we solve for C in the regular Pythagorean theorem. So we have a triangle here. You can see A is 12, B is 5, and C is unknown. We don't know what our hypotenuse is. So we write our Pythagorean theorem out using those values. And then we solve to get C, which in this case is 13. Let me show you another example of that. Here's one where you're not given the drawing. Now, how do we know which one? Well, we don't. We just have A and B, and it says A and B. So, we want to find C. There we go. 3 squared plus 4 squared is C squared. And that's how we solve it. Pause here to just kind of absorb what you see. All right, what if you're given the hypotenuse, but you got to find the leg? Well, you write the exact same, use the same formula, but you leave one of the legs out of it. So in this case, B is what's missing, and you need to plug in your 6 and your 10 in the right places. That's the really important thing. When you're finding a leg, it's just a slightly different thing, and we're going to do some subtraction, as you can see. Now, for those of you who get this really well and don't want to be bothered with all of that, let me just show you what I've actually done here is I've taken the A squared plus B squared equals C squared formula, and I've already done the subtraction. So I've set it up where B squared is all by itself already, and I'm going to take the hypotenuse and subtract the other leg squared. Okay, so the hypotenuse squared minus the leg squared. So that's what the 10 squared minus 6 squared is. And you can see all the same numbers are in this one as the other one, and I get the same answer. I just didn't have to move the 36 over there to the 100. I did it ahead of time. So if that way makes sense to you, it's actually easier doing this on the calculator. So use that if you can. So what is the converse of the Pythagorean theorem? So, if C squared does equal A squared plus B squared, then you know you have a right triangle. This only works with an equals when you have a right triangle. But what if we don't? What if it doesn't equal? What happens? Well, we'll tell you that in a minute. Let's talk about what the word converse means. Converse means reverse. Okay, reverse. Converse. And the converse is also true. The reverse of it. Let's see how we do that. So, we're given these two sets of side lengths, okay? 5, 6, and 10, and 6, 8, and 10. And we're going to test them with the Pythagorean theorem. So let's set this up. We're going to use, always the longest side is our hypotenuse, so that we know to stick it on the C side. So C squared, does it equal A squared plus B squared? So does 10 squared equal 5 squared plus 6 squared? Let's see what we get. So 10 is squared is 100, and of course the other two are 25 and 36. Add that together. Does it equal 100? No, it doesn't. So this one is not a right triangle. Okay? Just that simple. Not a right triangle. Let's take a look at 6, 8, and 10 now. Are we going to get luckier there and have a right triangle? There's our 3 numbers in the Pythagorean theorem. We've multiplied them out. We've squared them all. And, yep, they add up to 100. So, yes, this is a right triangle. Very simple. So, verifying. Is this a right triangle? Doesn't really look like it. And it's got that weird square root of 113 for the one side. So, I want to show you here. I am still going to square, okay, the C. This is the longest side. And And I guess how would you know that? Well, take the square root of it on your calculator and you will find out the value to know that this is our C side. Okay, this is our longest side. It is longer than the 8 or the 7. All right, but we'll show you that in a second. So we're setting this up, and I put a question mark over here because I don't know. Does this equal these two squared added together? Well, let's try it out. So the square root, we don't have to take the square root of 113 though, but if you were to test it, okay, if you were to test it, the square root of 113 is bigger than 8, okay, so that's how we know this is the C. Anyway, so when we notice I ended up here with 113. Now how did that happen? This was the square root of 113. That was our actual number, all right, and I squared it. So the square cancels out the square root and just leaves me with the number. Get it? All right, so the other two squared, here they are. Now, add these together. Do we get 113? Let's take a look. We do. So this is a right triangle, even though if I really look at this, that does not look like a right angle to me. You know what? Pictures can be deceiving. You can't go by the picture. It can look like a perfectly beautiful right triangle, but if those sides are not marked correctly, it isn't. Here's another example of that. That looks like a beautiful right triangle, doesn't it? Right there. That really looks good, and this is the largest side. All right. So let's plug them in and see if it really is. There's our formula all set up. There's our numbers all squared out. It's looking pretty good to me. It looks like 225 plus 1296 just might be 1444. But no, it's not. This is not a right triangle. Even though the picture really looks more like one than the picture on the last one did. Okay, so inequality. Our triangles, the sides are not, or the Pythagorean theorem doesn't work. It does work always for right triangles. But what if it's not equal? Well, as we know, if c squared is equal to a squared plus b squared, then it's a right triangle. We know that. But if c squared is bigger than a squared plus b squared, then we have an obtuse triangle. And that makes sense because c squared, the big side, is bigger than our triangle is going to have a bigger angle, bigger than 90. That's obtuse. And the converse is true. If c squared is smaller than a squared plus b squared, then the angle opposite it is going to be smaller than 90. So it's going to be acute. So that's how you can remember those other two, how to know without the chart, which of course we do have the chart. And it is waiting for you in the help sheets. So select the expression that can be used to prove that the triangle below is a right triangle. Let's think about this. So what we have here is, we have 8, 15, and 17. So 17 is our hypotenuse. 8 and 15 are our legs. So let's take a look at each of these, and let's see if they're set up. Now, I have to say that, first of all, the couple things. The Pythagorean theorem, for one thing, does not have a greater than equal sign. Okay, that's one thing true. We're looking for one that has an equal sign. Also, the other thing with Pythagorean theorem, things are squared. There's nothing squared here. So A is not it. Let's take a look at B. All right, so we got our equal sign. We've got some squares, but wait a minute. Don't we square each of these separately, not after we add them. So B is not it. All right, I'm going to jump down to D because I'll tell you right now, C is the answer. But take a look at this. They did the same thing here. All right, adding them first and squaring them. And then they did this little deal. So you know this is not it either. That's why if you see here, A squared plus B squared equals C squared. That will prove whether or not this is a right triangle. So your answer in this case would be C. And is it my buddy Tiger that says always choose C? Was that you, Tiger? All right. This next series of questions are going to be a little bit thought-provoking, so don't rush through them. Read everything carefully. Choose the response that correctly describes. So think about it logically. right, now it's time to prove. Can you tell me, is this going to be an acute, a right, or an obtuse triangle? Almost the same question. Notice I changed something. All I changed right here, or right there. Well, what kind of triangle is that one going to be? And once again, all I changed is right here. That's the only change I made. Which one is it? If you got the other two right, you can get this one right. All right. Now, I just, again, want you to think about logically. What would happen to this side if it were to meet the end of this? Okay, are we going to make this angle larger or smaller? Will it become acute or obtuse when we're finished? Same thing here. In order to make this meet up with that, are we going to have to enlarge this angle, open wider, or are we going to close up this angle? Read this carefully. All right, now this one's going to take you a little while to think about. Read each of these explanations and pick the best one. What's the logical one? Last question, at least in the video. All right, for those lengths, plug them into the Pythagorean theorem. Which answer is correct? Okay, we're at the end. This was the last lesson in Pythagorean theorem. We're going to do some review in the next few days before our test. Phew, so how do you feel? Are you starting to get it? Or do you feel like you're just running a rat race like that poor little ball, never ending and never quite looking like it could actually happen? No, that thing could not happen. All right, thanks for watching. Have a great day.